Hey guys, this is Sanjay from FTC Team 7477, Super 7. Today I'm going to be talking about bit manipulation in Java. So, bit manipulation is a process of directly working with binary digits, also known as bits, to perform operations efficiently. This topic is often used in competitive programming, low-level programming, and even system design. So first, let's talk about what even is bit manipulation. So, every piece of data in a computer is stored as binary. So, binary is just base 2. So, every single number in binary is just zeros and ones. Bit manipulation allows us to operate directly on these bits, giving us speed and control that higher level operations can't really match. Java provides bitwise operators to perform these operations, such as AND, OR, XOR, NOT, and shifting. So let's explore each operation. So first, I'll show the code, then I'll explain it as usual. So I'm just going to import java.util.all, just in case we need to use anything from that. First, I'll start my class, so public class. My class name has to match my file name, so I'll just have main. Then we do our main method, so public static void main string and args. So now let's get to coding. So to show how we can use like bit manipulation and binary operators, we can just initialize some integers, right? So let's have a equals 3 and b equals 5. And what you can do with this, right? So let's just print this out using IntelliJ's built-in shortcut. So essentially, the operator AND, it compares each bit of A and B, and it returns 1 if both are 1. It would be helpful to include the binary, like the binary representation of each number. So binary of A is 0101 for free, and for B, it's 1011. Sorry, 0011. So using our AND operator, it compares each bit of A and B and it returns 1 if both are 1. So let's just do that. So we can just print A and B. And then we can add on like the actual operation. So we can concatenate the actual operation. So we have A and B. So this is using our AND operator. Next, we can move on to the OR operator. So our OR operator essentially returns 1 if either bit is 1. So let's print out the same thing. So we have A or B. This symbol is, you may not see it on your keyboard. It's just shift backslash. So that's how you find it if you don't know. So then we can just concatenate A or B onto it. So we have A or B. And so this is our OR operator. Next, let's talk about an XOR operator. So what it does, it basically returns 1 if the bits are different. So let's just do the same procedure. We print it out, and you have A. It's denoted by this symbol, the caret sign, which is also used for giving the power or something. And then we can just concatenate A caret B. This is not necessarily saying that it's A to the power B. We're using binary operators, so yeah. Do with that what you will. So this is our XOR operator. Finally, last but not least, let's talk about our NOT operator. So our NOT operator, it just flips all the individual bits of the number. So what this does, sum.out.println, we can just print out. Yeah, we can just print out negative A is equal to, and then we can just concatenate like the actual operation onto it. So we can just print out negative A. Next, let's talk about bit shifting. So, bit shifting moves the bits of a number left or right. So, let's display this using our already existing integers. So, let's just initialize a number, right? We don't need two numbers. Let's just have it like 8, right? So, essentially, we can print out the result of bit shifting. So, left shift, left shift, it shifts bits to the left, effectively multiplying the number by 2, since it's binary. So left shift, which is, it's known as num, sorry, since you have a, it does a, that one, and we can concatenate the actual operation onto it, right? So we can concatenate a left shift 1, and this effectively gives a the new value of 16 in base 10, which is around 1000 in binary. Because we have a left shift, you would think that we have a right shift. Well, you're thinking right. We do indeed have a right shift. So let's do the same thing using the built-in shortcut. Right shift, it uses the same character, but a different way. I mean, not the same character, but just flip. So we would use the greater than symbol here instead of less than. So we have a right shift 1. Now we can just concatenate the result of right shifting it. So we can have a right shift 1. So if we print this out, it returns, sorry. Yeah, I have to add a space between those, sorry. Alright. So if you can see here, when we shifted a to left, it effectively multiplied by 2. However, when we do that for the right side, it just divides it by 2, which is how you can use bit shifting. So, bit manipulation has many real-world applications, such as finding subsets, counting the number of ones in a binary representation, checking powers of 2, and optimizing memory usage. Here are some key points about bit manipulation. Bitwise operators, which are your AND, XOR, OR, and NOT, work directly on binary operations. You can use right and left shifts, which are these and these. You can use them for fast multiplication or division by powers of 2. Bit manipulation is critical for optimizing performance and solving complex problems efficiently. Thank you for watching a Super Saiyan programming tutorial, and see you next time.